I brought this one up because this is a good example of it's an okay, but what I like to see is we want to be within 6 to 12 inches of the header, and we want to have 1.5 inches of insulation with a white PVC wrap around it. This is okay, but still it's not enough insulation, and the sun will heat it up even though it's reflective surface. We want to keep the moisture off of it. We really want to be, on this case, I would have chosen the white pipe because it's thinner and heat transfer is quicker. The way this was mounted is going to cause a lag in our temperature reading because now we're heating up all that stainless steel pipe.
Yeah, exactly. So that's a good point. So location is very, very key.
Very important. And if you have a double condenser, like a BAC or a Guttner, this is a BAC. This is not the pipe. That black insulation down there at the bottom is not the proper selection for placement. It's all fine and dandy when you're in liquid mode and you're subcritical, but when you go transcritical, and even on an adiabatic condenser, you will go transcritical. That is going to cause you a lot of heartache.
Welcome to CO2 Experts. Super excited. You guys have been here the last few weeks. We have experts from all around the world joining us. And this week I have Paul Binette, field startup. Me and Paul, many years chatting about it. I always bounce stuff off him. We're bouncing stuff off each other just to learn from each other and grow, because he's out in the field day in, day out, starting up in some of the toughest conditions, different racks, from indoor racks to outdoor racks, in warm climates and cold climates. And today we are going to be diving into procedures on startups, on commissioning, and troubleshooting racks. Super excited about this. Paul, welcome to CO2 Experts. How you doing, brother?
Good. How you doing, Trevor? Actually surprised the trainer of the masses has time to actually talk to me.
Oh, come on now. Come on. I love this. I love our conversations because I'm always learning from you, and we're both doing the same thing. You're out there actually doing the rack startups, but you're training all the time. And we'll get into that because this is very important in our industry. All of us, all of you that are on the call today, all of you that listen on the podcast, all of you watching on the YouTube channel, we all want to uplift the industry. We got to share the knowledge. Today is a day that we can all help. We got less and less people coming into the industry. So let's share as much as we can with everybody we can, or at least who wants to listen to get better and level up. So Paul, we're going to be diving into field startup. You've done hundreds and hundreds and hundreds of CO2 startups under your belt. And what are some of the things that before you even get into a site, or even before before you're at the site, what are some of the things that the contractors or technicians should be looking for before you get there?
Well, I learned way back in the beginning when I first started showing up on these job sites to get in contact with the contractor, because they need to be vacuum is done, pressurization is done, the rack needs to be under CO2 pressure, the cases all need to be communicating online, all the electrical peripherals, anything needs to be attached. So when I'm on site, I can concentrate on getting this rack started, testing all the systems, and checking alarms through the week. Because if I do a startup on Wednesday, because we're troubleshooting Monday and Tuesday, and we don't get a lot of time in the rack, and that's not a good.
Yeah, I was actually talking to a field startup manufacturer last week, and he said he went out to the site. The contractor said they're ready for him. So he goes out to the site and he gets there. The vacuum, they're still not even on the vac pump. And we're talking about tens of thousands of CO2 that goes into the system. And he's like, Trevor, I got there. I'm out there terminating all the terminations. Is that part of your role? So any manufacturer, is that part of your role, is going out and to do determinations, Paul?
No, sir. We actually have on our prints all the stuff that's field terminated, but I could say I sympathize with the guy because I've done the same thing to try to get things moving, because, I have a limited time when I'm on site. So I want to spend that dedicated to getting the rack up and running, getting tested, get everything tested, make sure we're running smoothly, the rack's charged properly, we got a good oil charge in it, and get some training time with the contractor.
Yeah. And I think that's the big thing. That's what they want too. A lot of the technicians I talk to, they're like, Trevor, I just really want to get a conversation with them so I can learn a bit more. But if you're out there actually just doing all the terminations, And I've been with a startup with you, you know what I mean? I've been at a startup with Paul before, and I saw what he does with the controls contractor, manufacturer, as well as the controls contractor and the mechanical contractor. It's a process and it's a team effort. So when that manufacturer rep gets out there, there should be some stuff in place. And I had Eric Holland on a few weeks ago from Advanced Europe, and he talked about his startup procedures as well. The biggest thing is that when the manufacturer come out, we should be ready. You know, we should be ready to have them, and they shouldn't be coming because there's hundreds of jobs out there that need to be done. And a day or a 2 day loss of their time is very, very important, just like a day of two of your time as a technician. So, Paul, let's talk about this first image here. So it looks like an indoor rack.
Yeah, this is actually a rack from Puerto Rico. I started up a couple months ago. It's one of two racks, first two CO2 racks on the island. This one here they were ready. It was supposed to be a 1 week job. I ended up staying 2 weeks because I was helping them with their EMS controls, getting their vacuums finished, actually piping some stuff that they had piped wrong. And so it was, we spent more time on the job than we really needed to. I have no problem. Contractor calls me a week or two in advance or a month in advance. I'll answer any question. I'll help them out any way I can to make it easier. So when I get there, we're ready to go, and it's an easy startup.
Yeah, because there's differences too. So some manufacturer will, would do more than field assist, because this is kind of what you're doing. It's a field assist. You go in, you verify with them the whole goal. Actually, let talk through on what that role is as you coming out as a field assist versus going to do the full startup yourself, like the contractor does the startup and commissioning. What is usually a manufacturer's role, or your role, when you go out to a site again?
My role is to go out and support the contractor with the startup, any issues with the rack. I will help with the cases. I feel their contractor should be doing the startup because he's the one that's going to be servicing it. He's going to want to be troubleshooting it. If he can't start it up, he can't do the ladder.
That's it. And I think that's
the biggest we also have our AMS group that does 100% from start to finish. They do it all, but I still think the contractor should be in there side by side, standing over their shoulder, being a bother, learning how this rack works.
Yeah. And I know this is an expense if you're a technician or a contractor. This is an expense, but this is where you're going to learn the most on startups. That's where you're going to learn the most, because that's where the crap hits the fan. You know what I mean? That's when all of a sudden compressor 3 is not running, or compressor 4 OMC or is not feeding. These are the things that you need to look for.
Yep, this is where we find if there's a wiring issue, and when you pull a couple thousand feet of wire, you're going to find one or two that's wrong. I don't care how good the quality control is. It's car industry. They ship it to the dealer, and the dealer has to go through it and prep it before he turns it over to the customer. Yeah. And they do how many cars a day? Yeah. So yeah, you're always going to find stuff. You're going to find mechanical issues because not everything's 100% all the time. This is not a refrigerator you bought at Lowe's. You take it home, you plug it in the wall, and turn the thermostat to where you want it, and it runs. That's not what this is. This is an assembled 100 parts on a job site, and then it all has to be tested and verified.
Yeah. And that's the big thing too, because they're different. Even though all the manufacturers, we want to make it as close as possible the same. If you put it in Southern California versus Northern Michigan, it's going to be set up a bit differently. You might have different components on it, different ambient strategies. So this is why understanding the equipment you're working on right away. So what are some of the things, this is an outdoor dry, what are some of the things that if a contractor called you a week before on some of the things that you want them to have done? And I know you mentioned already, but it's good to go through it again.
Yeah, I would go through, actually have just a really quick 5-point checklist. Is the rack ready to run? It's under CO2 pressure. You did a pressure test. You did vacuuming. Is the electrical components done? I walked at the job sites where the main electrical power wasn't even connected.
Wow.
So yeah, I want to know right in advance that all this stuff's done. Have all your peripherals been attached? Your leak detectors, your valve stations, all the loose ship parts that we ship are connected and installed. And overall, do you have the correct CO2? That's been a problem here lately.
Okay. Okay. Do you want to elaborate on that?
Yeah, originally we spec'd Coleman grade, refrigeration grade, instrument grade, laser grade CO2 for our system. It's 99.999% pure. After the pandemic, there was an issue with a couple of the manufacturing plants. Alabama was shut down for maintenance. Mississippi plant found acetone in their water and had to figure out how to get rid of that before they could start producing CO2 again. So it was shortage. We lowered that percentage to a 99.9.
Okay.
I know it doesn't seem like much, but the difference between 99.9 and the next two nines is the purity, the moisture, and the non-condensables. Yeah. So if you do use a lesser grade, you're going to have to take steps to make sure you have no moisture going in, make sure you're charging with filters, do a non-condensable test after you get the rack starting.
Yeah. And this is the thing I talk about to people all different around the world. You look into manufacturer specs, and different manufacturers, they'll spec different quality of purity of refrigerant. Here in Canada, it's bone dry. So it's 99.8, which is even less there. But once again, you have to put things in place. Filter dryers, replacing them. You can't just use one for 10,000 pounds. And it's important that you have to do these checks as well. And I talk to other people in Europe. No, it's 99.99. So N 4.5. So 5 nines or 4 nines and an 8. You know what I mean? So that the moisture level, the biggest thing that I've learned, because I did a lot of studying on it, you don't want to go too low. It's not because of the moisture, because you get more moisture, because you can pull the moisture out, right? With filter dryers, it's this other gas, the other non-condensables, like you say. Filter dryers don't pull those out, like argon and any other types of gas. So that's why you want to worry about how low you do go. So always go with what the manufacturer recommends in putting the system.
Yep. Yeah. Something else I want to hit on while we're talking about the startup, the pressure testing for the system. Everybody's used to, we're going to start up an HFC rack. We're going to take it up to 150, 200 pounds, and it's good. Well, with CO2 racks, there's a greater step. Your low temp is pressure tested to 350. Your medium temp pressure tested to 500. The discharge piping is tested to 1400 psi. You want to make sure that the joints that are out there have been brazed in place are going to hold.
And that's different in your jurisdiction, because here in Canada, you got to do 10% above the pressure relief. So if you got a 1900 psi pressure relief, for an example, you got to pressure test over 2000 psi. So make sure, depending on where you're doing this, because there's people listening from around the world, follow your local codes.
Exactly. And in your case, you guys are popping off relief valves and blanking them off to be able to do that.
Yeah, so you got to take you got to blank off the compressors, you got to blank off the pressure reliefs and pressure test that way and hold it for over 24 hours. So there is codes. I've actually had contractors here in Canada say they had to cut out a bunch of sections of the pipes because there was no verifications when the inspector comes in. So you might be getting away with some of this because you don't have inspectors, but at some point someone's going to go in and check it. It's kind of like joints here. Like we have some stores where the inspectors will come and they say, we want you to cut out that section. We want you to cut out that section. And you want to cut out that section to check to make sure the penetration is there. Once again, this might not be happening in your country, but it does happen here. And you just don't, that's a big cost and burden on the business. And I'm sure you've seen like things like that in the past, Paul.
Oh yeah. We have customers out there that specify that they're going to come in and they're going to cut 10 joints. They want to know if you're blowing nitrogen, how well the joint's sealed. And if you fail that test, they can cut 10 more. And from there, it's just a bad day. Yeah. When you got to repipe the whole store.
How about I'll throw this one at you, Paul. Have you ever seen where, because now we're doing high pressures. On our high side, we're running 12, 13, 14, 1500 PSI, 100 bar. Have you ever seen where a contract, because we're used to just going into a 54-foot trailer, grabbing whatever copper pipe's there and putting it up. Have you ever seen where they put the wrong copper in the discharge line? Because instead of high pressure copper, they're using K or ACR?
Oh yeah, we've had a couple jobs like that where we go to start up, and because that's one of our checkpoints, it carries a magnet. Real simple test. Tap it with a magnet, and you can also tell by the color band that's on the pipe. Plus, it'll be listed at 130 bar. But yeah, we've had a couple contractors, we've had to have them cut out and repipe the discharge.
Yeah.
So yeah, it's happened.
And this is just a learning curve. I don't blame those technicians because they're probably just used to doing the way they've done it. It's a 2-in-1 pipe. It's a 2-in-1 pipe. Just grab it and go up. But the high pressure copper is definitely strong. Any other questions on this outdoor rack? You know, you got a computer there. You got some compressors.
No, this is actually one of our first Copeland startups with Quick Trip.
Okay.
Went real nice.
Awesome.
This rack is our new Flex 2.0, and
this one here
is our new design going forward for small format stores.
Okay. Oh, that's good to know. It looks very open and clean. Layout. What I do like is that everything is labeled. I know I've been to quite a few of Hill Phoenix and sites. I like the labeling, and I think more and more manufacturers, this is what they're starting to do too. Versus when I used to work 20 years ago in the field, everything used to be black. A lot of the labels wasn't. They might have been there, but I don't remember being labeled as good as CO2 systems today versus HFC rack before.
Yep, and in our new rack design, we took the electrical cabinet and made it its own component, and moved all the controls to another cabinet, get them out of the interference that can come from the electrical cabinet.
Yeah, we're seeing more and more of that stuff in our industry because we got more electronics now. We got hundreds of controls. We got VDCs. We got lots of different stuff. Do you want to talk about that, the evolution going from, we always had EMSs, you know what I mean? The E2s and microthermals, the Danfoss with some control, but now we're going to more advanced CO2. We got case controllers everywhere. So we got controls controlling controls. I want to talk a little bit about that.
Yeah, well, we've squeezed all the energy we can out of a mechanical system with mechanical valves. If you want to go forward, the next step forward on any evolution is going to be going with controls on everything so that you can micromanage it. That's the only way you're going to get more energy efficiency out of them. How long ago did they get points out of the cars and went to electronic ignitions to make it more efficient? Yeah. So yeah, it's people are saying it's CO2, but it's not. Going forward, HFC systems are doing the same thing.
Exactly. Yeah, and I'm seeing it out there too. All these newer refrigerants or HFOs, all those ones are all electronics too. So you got to start learning this stuff. Maybe you might be just working on mechanical stuff now, but it will be coming. You will be seeing it so soon. So on this slide, we're seeing some pressure transducers, an analog gauge. What do you want to talk about here for startup and commissioning?
Yep. So the reason I put this in here because one of the main startups that I take care of, but should be the contractor's job, is you have to verify everything on the rack. You got to make sure that the medium temp suction transducer or medium temp suction temp sensor are actually wired to that, because they're really close to each other on the control boards. It's not hard to make a mistake. Yeah. So we verify all this prior to startup. We check our transducers, we pop them off, make sure the one off is the one that's going down on the control board. I don't care what it is, Corel, Microthermo, Danfoss, Copeland, they all have inputs. Yep. We want to make sure that, one thing I like to do when we have 150 pounds of pressure prior to startup, or whatever the contractor put on, even if it's 200, go through every controller, look at them, make sure all the transducers are reading. This is a good time for you to find out which transducers are reading and which ones are close. Because if you got all of them are 200 and one's at 75, you got a problem, and you need to look at it before you start the system up.
Yeah, and I think I've heard this from I heard this from a lot of field startup people. A lot of technicians want to get the gas in right away, where the last thing, the CO2 goes in quick. It's all the pre-planning before the CO2 gets in there, before the field startup guy comes from the manufacturer, because the biggest process is doing all these checks, because there's thousands of sometimes temperature and pressure probes in a system. Could be. All
right. So when we're doing our checks along with our solve the question, in the old days, you would start a compressor, you would close the discharge valve until you trip the discharge switch. Yeah, we don't do that on CO2. The way you test it is just take the screw out of it and pull the cap off and watch your proof signal go to off for your compressor.
Okay.
Because
There's still
Okay.
technicians I talk to, even on CO2, is that they do it the old way, but it's you need to know what you're doing. You have to do it safely.
Yes, because in a very quick way, you can go very bad, and that 2155 relief valve on the front of that compressor can come into
right in your
play.
face. Yeah, right in your
Yes.
face. So you gotta you gotta know what you're doing if you're doing it that way. So you pull off the wiring.
I
So
pull off the supply cap that goes to the switch.
We got an image there in a little bit. Let me just pull. I'll just go to it right quick, just because that was a good question that was asked right here. Right, this is the one you're talking about.
Yep, that one right there.
Yeah,
That's
so you pull
110 bar, 117 to 115. Yeah.
Yeah, 110 to 117 bar, like almost 1600 psi to 1700 psi. So you'd take the screw off. Yep.
Go ahead.
You'd take the
Well,
screw off.
I can tell you from. Go ahead. Sorry, your turn.
Yeah, you'd take the screw off and you would unplug it from this device, right? The wire.
Yes, sir.
Okay.
Then you're going to go through and look at your proof, and your proof should go off from on to off.
Yeah. And then all of a sudden,
I can tell you, testing it with a wrench, the CO2 pressure builds up fast enough that it can go right past that switch and hit the relief valve.
yeah, look there. So shutting off the discharge valve on any compressor is not the way to test at high pressures, regardless of the refrigerant. So there's some people in the box. So thank you. Okay, so very good, big tips there. Fantastic. Okay, so next slide, we're talking about the gas cooler sensor locations. This is the ambient sensor, I believe, location.
Hold on, back up one. Let's go ahead and go through all our tests.
Okay, yeah.
For pre-startup. All right, so once we verify, and it's way easier to verify all this to make sure your HP, your high pressure valve, and your gas bypass valve are moving before you put liquid in it. Because once you get liquid in it, then you're going to have to deal with the outcome of not being able to control your pressure. All right, so you want to. It doesn't take long once you get all this stuff done. You've gone through. You've tested your oil switches before you put oil in, and turn your breakers off. Turn on your control circuits. Let your oil switches go through their time sequences and trip. You want to see that they're tripping. Your wiring is good. You want to make sure your HPV valve is calibrated. Your bypass valve is calibrated. Calibrate it per the control manufacturer's recommended steps to do that. Then we're going to go into filling our oil system. When you charge your oil system, you're going to charge your receiver. We don't charge into the compressors like that, like we used to. We're going to fill up our reservoir. We're going to isolate it. Then we're going to put 300 pounds of pressure on it, and then we're going to manipulate the switches and let the compressors fill. And then we're going to let the switches shut themselves off. We want to see that whole system work. All right. Once we get all our testing done and verified all our sensors, now you can go down to the condenser.
Yeah.
Yeah, switch down to the condenser.
Oh, yep.
So on an ambient condenser, we use our control strategy is a 10-degree TD. We have a minimum temp and then a maximum temp. At the minimum temp, the fans shut off. At the maximum temp, the fans run 100%. In between, they modulate to control the drop leg setting, which is a floating setting for us. We have a flux combiner that takes the ambient plus the condensing PTR to determine the PT and get the 10-degree differential for our condensers. So sensor placement is very important. You don't want that ambient sensor out in the sun where at 70 degrees, it might think it's 100 degrees, and that's going to really mess up your condenser control. So we like to get it up underneath, and this is where we mount it today. You'll see we've got it up underneath. We're mounting it in the airstream. It's just like on an adiabatic. I didn't think I would have sent a picture of an adiabatic.
Yep. Now I'll maybe be able to pull one up in a little bit. Let me look through it.
What's that question? What was that question?
When we use adiabatic pre-cooling pads in the gas cooler, should we tell the controller the actual ambient temperature or the temperature of the air after the pads?
Well, so I want everybody to think about that. So if we're trying to maintain a 10-degree TD and we've got an adiabatic condenser and we're dry, we're below the minimum fan speed and the minimum cutting temperature. We can use either or, but when we switch, which one do we want to control off of? Of course, we want to control off the ambient pad sensor, or the temperature between the cellulose and the condenser. Otherwise, we're going to have an erratically operating condenser because we're going to be reading the wrong temperature. So on a adiabatic, the ambient temp sensor is the pad temp.
Yep, great, love it.
Yep, we want to make sure that, go to the next one.
Yep. This one here?
I brought this one up because this is a good example of, it's an okay, but what I like to see is we want to be within 6 to 12 inches of the header, and we want to have 1.5 inches of insulation with a white PVC wrap around it. This is okay, but still it's not enough insulation, and the sun will heat it up even though it's reflective surface. We want to keep the moisture off of it. We really want to be, on this case, I would have chosen the white pipe because it's thinner and heat transfer is quicker. Because this is the way this was mounted is going to cause a lag in our temperature reading. Because now we're heating up all that stainless steel pipe.
Yeah. Yeah, exactly. So that's a good point. So location is very, very key.
Very important. And if you have a double condenser, like a BAC or a Guttner, this is a BAC. This is not the pipe. That black insulation down there at the bottom is not the proper selection for placement. It's all fine and dandy when you're in liquid mode and you're subcritical, but when you go transcritical, and even on an adiabatic condenser, you will go transcritical. That is going to cause you a lot of heartache. So we want to pick a side. I like to.
Yeah,
we want to pick a side. I like picking the side that has the pad temp sensor on a BAC. That's going to be the side facing us. On a Guttner condenser, it's going to be the opposite side. And we want to be, again, within 6 to 12 inches.
I know that, yeah, we've done this conversation on this before. I had some people in Australia, they say they have hundreds and hundreds of installation, well, not hundreds, but they got about 100 installation where they put it down there, and that's where they recommend it, is where where you get both of them. So you've seen erratic, just so I know, like you see erratic high pressure valve functioning with it there in transcritical mode?
Yes, sir. Literally, I had a job that I was starting up that it was post-pandemic, where we were using a different manufacturer for our condenser, which was literally 1.5 feet shorter than our normal Levada. And our temp sensor ended up just 3 feet away. When I started the rack up, I kept tripping on high pressure. I had 3 or 4 cases on. I couldn't get the valve to stabilize. And literally, temperature difference from the outlet of the condenser to where the sensor was mounted was 7 or 8 degrees, because it changes so quickly with CO2. And Advancer Europe is the same as us. It's got to be mounted on that right up to 6 to 12 inches of that header.
Yeah. Oh, good.
Because we've had the discussion with them also.
Yeah. No, and it's fair. It has to be tested. You have to see it, and this is what'll happen. You can run into issues. So make sure you work with that manufacturer and ask them where to do it. Why? That's the biggest question. You're explaining the why, right? This is why you want to ask the why to those people. So, and this is the most important sensor. This drop leg temperature sensor is the most important, and I've seen it as well as Paul probably dozens of times. Not in the right location, or not strapped down properly, or not insulated properly, or the wrong sensor, a CPC sensor into a Danfoss controller, or vice versa, not set up properly.
Yeah, because once we go supercritical, the HPV, which is reading this sensor, needs to follow a track set of data points that's pre-programmed into the controller. And if you get to either side of that because of the temperature difference, you're going to produce too much flash gas. You start producing too much flash gas, that's more work your compressors have to do, and takes away from the suction control.
Yep. Yeah, I love it. I love it. Next image here is field wiring, temperature sensors.
So, so this sensor in that last picture are the exact same job. I got a call up on a customer that was running for 3 weeks, and 10 people looked at it and couldn't figure out why we were having so many problems with it operating. And I got a call at 9 o'clock on a Friday night. Start talking with them. I start asking for pictures. And then when I got that one picture down below, I had a close-up, had one sensor. So we literally had the fan drop leg, the HPV sensor sitting in the cabinet right there. So how was that going to control? During the day, it was trying to go supercritical because the temperature probe was reading 100 degrees. So these sensors that ship loose are rolled up in the cabinet. They're on the prints as field mounted, have to be mounted by the contractor.
Okay. And so this is already wired up. It makes it even easier too. You just have to go and mount it. 7, what is it? What do you recommend? 7, 9 o'clock? What's depending on the size of the pipe? Where do you recommend?
Yeah, we do 7 and 5. 7 and 5.
Yeah. And insulate it. This is so important. So now your high pressure valve is going to be all over the place. So.
Oh, it was. Rack crashed a couple times.
And then you never want to leave wires like this. If you do it properly, you cut the wires, make it the right length. If you're just leaving rat nests in there, it's not helpful for the next technician coming out. Like, what is this? Who's doing this? We're professionals out there. So this is another one of field install of a temperature sensor into a board.
We mount them like this so the contractor knows where they get landed. Makes it easier for him. He doesn't have to hunt for it. And then he disconnects it if he's got to extend it using the whatever type of extension wires specified in the EOR drawings to extend it.
Yep.
But it's got to be mounted. This is one of those. It is the contractor's job.
So this is another one where they didn't mount the gas cooler outlet temperature. But okay, well,
this was actually the ambient temp sensor for the same job.
Oh, so the ambient is just rolled up. And once again, guys, you want to clean this up. You want to cut this, make it short, and then make it look a lot better, right? Clean it up for the next guy that's going to work on it.
I used to have a saying. It's called pride in workmanship.
Yeah. Oh, for sure. We're in refrigeration. You gotta have pride in what you do. So the next one here is we got some Bitzer oil cans.
I wish I'd had this one on the right is actually the German brand of the oil, and the one on the left is what we get here in the U.S. I needed to have a picture of the Copeland oil because now we are shipping both Copeland and Bitzer. You have to ensure that the system you're starting, if it's a Copeland or if it's a Bitzer, that you get the correct oil because we've been shipping Bitzers forever, and we did ship a Copeland rack with Bitzer oil, and the contractor caught it 2 weeks in advance and call me up. I got the right oil delivered. Make sure you have the right oil on site.
So because Bitzer uses a BSC 85K, and depending if it's subcritical, they'll use a different oil. And then Copeland's a 68 pound, I think it's RL68. Yeah. Is that right?
That's correct.
Yep. Fantastic. And so now we got an image of CO2 cylinders and a little bit of the differences.
Yep. So the reason I put this up here is make sure you have the proper CO2. And of course, we don't want the one on the right. That one on the far right is what you see behind McDonald's, and that is some dirty stuff. Now, let me say, and if you're in rural Kansas, and you can't get but what you can get, but you need to get the customer up and running, you do what you got to do. Yep. But you need to filter it, and then you need to run it, and then do a non-condensables and vent any non-condensables. And if you're on a system where the condenser and the vessel, the flash tank are equal, or the condensers below the vessel, you're going to have non-condensables in your flash tank too. So be aware of that. That's another place you'll want to bend them off.
Yeah.
So this
the highest point.
Yep. And don't set your bottles outside in the winter. You want to have a minimum of, I think we just put something out of, for Canada, a minimum of 700 PSI on that thing. That's like 52 degrees.
Yeah. So
or
outside is
70
not going to
degrees.
work here in Canada. 52 degrees is it's lower than that here right now. And the sun is shining.
Well, I just helped write a startup procedure for starting minus 35-degree weather. I said, well, there's two things wrong in that statement. Who's going to be out in the minus 35-degree weather with a 40-mile-an-hour wind doing a startup? Somebody's going to have a tent up, and there's going to be heat of some sort.
Yeah, you do. And that,
Would you disagree, Trevor?
no, it's seriously like I was last year at a site startup with a contractor, and they had moisture in the system, and it's super cold outside. So they had to take a whole blanket and cover up the whole rack because someone left something open, got water in it, and so couldn't get your pump's not gonna. If you got water in the system and it's cold out, your pump's just not gonna get it out. So they put a whole blanket over it, like a massive tarp, insulated tarp, huge, and then had heat pumping in for a week and a half, pumping in the heat and just pumps on it, just trying to pull out that water out of the system. So this can happen, which is an issue.
This wasn't the job with the control panels that sweated, was it?
No.
Because we had a job up there where the electrical contractor ran his conduit from downstairs up to the rack and didn't seal it. And the rack sat there for 3 weeks with heat downstairs, and they're heating with Bunsen heaters. And that hot, moist air was going up the conduit into the control rack, and literally it rained in the control rack. And we ended up changing out some stuff.
Yeah. And there was another one even last week. They left the gas cooler lines open. I talked to, and it took them forever to get the water out. Like it just filled up.
Yeah.
Like that someone didn't cap it, right? And because sometimes it's not refrigeration contractors working on it. Now we got welders inside welding this up, and then it's Friday afternoon, 4 o'clock. Okay, I'm done. I'll come back and I'll braze the rest on Monday, or I'll weld the rest on Monday. But you got to cap that stuff. So you got to. I've been noticing more and more the refrigeration technicians have to keep a better eye on the welders, because we use a lot of stainless steel here in Canada. There's always better ones than other ones, right? So just keep an eye on it.
Good point. And in the U.S., I don't know about in Canada, but the U.S. is getting, it's getting harder and harder to find refrigeration contractors, especially with all the CO2 change outs that are happening. And some people are hiring HVAC contractors, and some HVAC contractors don't have the basic piping practices of refrigeration contractors.
Yeah. Oh, and it's all taking pride in your work, learning how to do it right. Something just jumped up in the chat by Dimitrios. Gained some experience in Iraq using PEG 68, and somebody added POE 85, and now the oil kept foaming and confusing the oil level sensors, which was always causing them trip out. I heard about that before too. So this is where you got to do oil analysis, oil lab tests. Have you talked to many of your contractors about doing not an acid test, an oil sample test? Do you guys get your contractors to do that, or the contractors out there?
Yeah, well, it's more on the owner's end because it's their equipment.
Yeah.
And right now, because of the issues that one of our biggest customers has had, that they are requiring oil tests every year.
Good.
And back to the foaming, especially we're utilizing the 130 bar Crevon modules on a lot of our systems due to request, and that optic eye in there will sense foam as being empty and continue to fill.
Yep. And that's a major issue. You can't just keep continuing to fill on there. So fantastic.
Yes, sir. So part of the startup procedures is verifying your valves. On our new Flex 2.0s, we're utilizing CCMT valves, which look more like a Danfoss CCM valve. We still have racks that utilize the ICTM valve. This valve it's a fantastic valve. It'll work off a 0 to 10 signal. You can manually manipulate it off a magnet, which is down that bottom left corner and bottom right corner, or you can put the controller in manual if you lose your signal or you're outboard, and actually run the rack that way. And one of the things I'd like to see, especially at startup, is you have to pull that valve off. If you don't, you're not doing something right, because you have to pull it off. You got to work that valve, make sure that it doesn't stick. It's nice, smooth, and it's a very smooth turning device. because it's magnetically coupled to the bonnet of that valve, and that's how it turns the internal mechanism. And you want to make sure that it's free, and you want to have it open for your pressure test and your vacuums.
Yeah, and it's so important. And this is how you learn too. Take it off and then do the recalibration. We've talked about this many times, and you showed me how to do it. And it's in the manual on how to do a recalibration. And this is what you should be doing at the startup, so you can see how it's done if you ever have to do it in the field. But you never want to take off really any valve controller and let it run, because now the valve itself doesn't know where it's actually positioned. So if you ever pulled this off and it's still adjusting or moving, and it moves to 100% open, and you put it on, but it's not really 100% open, it's going to not know its position. This goes with really any valve manufacturer. So just make sure you don't do that. And if you do, you got to recalibrate it. Make sure it goes home and it's 100% closed.
If you feel you're having any issues with your HPV, I tell everybody every year when you do your maintenance, you change your filters, you change your separator, you change your suction dryers, you check and clean your inline strainers in the oil feed lines to calibrate that valve. You know, you calibrate that valve, you calibrate your transducers, you calibrate your temp sensors, because those are what keep your rack working efficiently.
Yeah.
All right. So
100%.
This is the bypass valve. So for some controllers, if you literally disconnect the signal line there and reconnect it, it'll force a calibration. Danfoss, Corel. I wish I could tell you about microthermal. I don't know.
No, that's fine. So this is the flash gas bypass valve. I threw a high pressure valve in there. I thought it was a CCMT, but this is a flash gas bypass valve. This one here.
Yeah, this is CCM. That's actually incorrect. That's a CCM. The T we would use on the high pressure side. The difference being is the CCM is literally a straight through valve, where the CCMT is in essence a TXV for creating a pressure differential. So it'll be a come in the top, blow out the bottom valve.
Okay, perfect. So that's my mistake on the slide there. So
no problem at all. We all make mistakes. That's how we learn. So you can disconnect the cable. If you have an old 326A, you can power cycle the 326A. That'll calibrate your HPV and your bypass valve. With Copeland's the same way. You just, on the XM controller, the bottom right, you pull off the big clip on the bottom right, repower the valve, power cycle it. It will calibrate the valves.
Perfect. And it's important to do that. You want to understand, because those are the two main valves that I think after the technicians learn how they work, the rest of it's just supermarket refrigeration, commercial refrigeration.
It is. The rest of it is standard refrigeration. Same thing we do every day. We've been forced into the technical world because of EPA regulations, but it was already headed that way. Yeah.
And the big thing is that we just need it's a change, right? All of this is a change for us. We're used to doing something one way for 10 years, and it's a change. And it changes hard, but it's not going back. It's not going back. So we got to learn to evolve with what's going on.
I know there's the naysayers out there, but CO2 is here to stay.
Yep.
All right, so one of the other things we do at startup, if we have heat reclaim or hot water reclaim, you want to check your valve to make sure you're circuited to, during the off position, it goes from compressor to condenser, not through your reclaim. So you want to make sure these valves are oriented correctly. You stroke them, give them a 0 to 10, and watch them go fully open. Take them back to 50%, watch them stop, and then go back to 0. You want to make sure this stuff works. This is what we call getting ready to start the rack. We're making sure that when you roll the windows up, they go up. When you roll the window down, it goes down. And when you push the window for the left, the right one doesn't go up and down. To put it in layman's terms.
And so this is something that you may have not have seen on a rack before. Belimo's, on your standard rack, you might have just had a 3-way solenoid valve. where you see more and more on CO2 racks where you're using like three-way actuator with a BLEMO actuator on it. I do have a quick question for you. I had someone call me up last week, maybe, asking about the stops here. So if you put this stop right here at 50%, that means it won't close or open over that percentage. Is that correct with these stops here?
That's correct. So one of the ones that I usually set is the bottom end. So say you're in a state where in the summertime it's so dry, the heat reclaim is not going to work. Let's say Arizona. It's dry, the store needs humidification, not dehumidification. So this valve is going to stay closed for 70% of the year. I want vapor moving through that coil, so I'll set that for 10%. That way we're always moving vapor through the coil. We're not allowing the AC condenser to condense 50, 60 pounds of liquid over on that side of the system, and we're not trapping oil over there.
Yeah. And these are different strategies, and you can manually open these, right? What's this? Because if you're doing a startup, you want to test it. Can you do a manually open and just to see if it moves?
Well, yeah, you can, but some of these three-way valves are quite stiff until they get worked in with the heat and some motion. But on the top of that valve on the right side, that back switch, you can push that in and manually manipulate the valve. You can also push it in and lock it in place, which will override and not let you do anything with that valve. Next thing I want to point out is on the bottom right corner, you'll see Y1 and Y2. That's the default position for the valve. So right now, I'm going to have to guess the default position for this is straight out at 90 degrees. So that would be on Y1. If we wanted it to go 90 degrees, we would switch it to Y2. So what that means is that when we lose power, it's going to go back to the default position.
Okay. And that's important. So yeah, very, very important. Then you got some lights on it. Some of them you can actually hook up a computer to them, depending on how advanced you get the BLEMO voltage. But basically, you're getting a 0 to 10 or a 4 to 20 milliamp signal into it from a board saying, we want you to open, we want you to close, or we want you to modulate. Have you used any with end switches on them in these ones here?
Yeah, so this rack, just getting ready to say that. So on this one, BLEMO has an end switch that literally fits over top of the handle, the black handle. And this was actually a pump down line for a split condenser on CO2 that we did. And as soon as I saw it, I notified the factory we needed to add an end switch because I needed to know when this valve was 100% open, and I needed to know when the valve was 100% closed, as well as the three-way valve. Because when I'm going into split condenser, I want the split condenser valve to be fully shut before I allow the pump down line to open. Because if you start these two together without a delay, then as we're closing and reopening the split condenser or closing it, we're going to overpressurize the vessel.
Yeah, and we don't want that. And there's other ones that I've seen where that if you have a three-way valve and you just have one heat reclaim coil, you do not want a deadhead. You know what I mean? All of a sudden you close your three-way valve going out to your gas cooler condenser, but your heat reclaim coil isn't open yet. Then all of a sudden you're going to go off in high pressure. That's one of the things that I've definitely heard from a lot of controls contractors saying, like the service technicians, if you're going off in high pressure, it may be the BLEMO valves. Like maybe they stopped working, maybe they fell off. I've even heard contractors said I came in, they sent me a picture and the BLEMO was hanging off the rack, so it vibrated it off. You know what I mean? So this is something that you got to take a look at.
Yes, sir. And well, also on another note on the BLEMOs, if you have a hot gas defrost system, we had, our high gas supply line, we had a BLEMO for the supply, an ICAD for the control, pressure control. And then you had your inlet header was another modulating valve. Well, that we found the modulating valve on the header moved slower than the BLEMO did. And we were deadheading for the first 5 seconds because our pressure was going up too quick on our high gas.
Yeah.
And what we ended up doing was putting a delay in this Belimo of 30 seconds to
Yep.
allow the other one to open before we allowed the hot gas to start flowing.
And yeah, in CO2 systems, like any ball valve, you want everything to open and close slowly, even though everything works very fast.
Yeah. Yep. So this is one of our new Castell valves. These are an Italian-built valve that we're utilizing in place of the old Sharp valves. And I'm guessing everybody that's worked on one of our old racks with had to put a cheater bar on the valve to open or close it. This is a pleasure, trust me. Even when you pump down the vessel, the differential of 400 pounds, it still opens up smoother.
Yeah. I remember I think when we were on the startup, they had like a 4-foot or a 6-foot 3-inch pipe to open some of those big valves. Like it was, they don't know.
Valve, that was a 3-inch valve, if I remember right.
Yeah, that was not an easy one to open.
One thing about the pressure switches, guys, be aware there's 2 different types of pressure switches. You have one for your 120 bar systems, which is 108, and then you have one for your 130 bar system, which is a 117. So be aware, don't just blindly order a pressure switch. Usually use your the serial number for one of our racks when you order your parts so that they get you the right parts.
Yeah, because this is the big thing that I talk about when I'm doing training on the high pressure valve and high pressure controller. There's steps, right? So you can't all just say, okay, well, I can run the high pressure valve to 1600 PSI when my pressure control only goes to 1508. So you're going to have the system fighting itself. So you just be aware of that setup.
Yep. Next thing, if you have ESRs on the system, you need to make sure that they're functioning and they're actually turning in the right direction before you go putting gas to your system.
Yep.
We don't use a lot of ESRs because with the new electronic controls, you can control your cases on multiple suction pressures.
Yeah. And that's a big thing. If you cross one of the wires across to one of the controllers, when it thinks it's closing, it's actually open, and vice versa. And this has nothing to do with CO2. This is just any electronic valve. So this is very important on startup.
Exactly. You want to verify the programming of this is why we come out, because we'll go through the VFDs and we'll make sure that they're programmed correctly. We'll actually go through the programming, do some spot checks, make sure it's right. If you got an ICDM valve, you'll have to program that. Other than that, today, all the iPro, the EVD Twins, the Danfoss 782 pack controller, the Microthermal 742 controller, now all that pre-programming is coming in with the rack control program.
Okay, so
we still need to verify our.
Yeah, so that means now that the main controller's reading the parameters that are already set up, so making it even easier for the startup, but we still have to verify that stuff.
Yes, sir. I would.
Yeah,
I would. The better the startup, the longer the longevity and the easier the service you guys will have on it.
A lot of people are, afraid of VFDs or setting up VFDs, and maybe not afraid, to just intimidated because they've not worked on them much. You want to give a couple of tips. This is a Danfoss one, the one in this picture, a very popular one on compressor control. Do you want to talk about some of the main settings they have to check on a startup, just a verification check? Because I know there's a lot of parameters in them, but you don't have to go through the 6,000 parameters or whatever, 1,000 parameters or 500 parameters. Yeah. What are the main ones they got to go in and just kind of verify?
Well, the ones off the top of my head are, you want to make sure that on your 1-2 settings, you want to make sure that the screen display is set up correctly. On your compressor program, you want to make sure you have the right horsepower, the right amperage, the right voltage, the overcurrent, and that's what you're seeing right there, that torque limit. Whoever programmed the torque limit to 100. It was at 100, not 300%. And it was causing these slow torque startups. You want to make sure how you controlling your compressors. Your Your compressor is at a 30 to 60, is at a 25 to 65. Copelands are 25 to 65. Bitzers are 25 to 75. Some versions of the compressors.
That's right.
And most of the ones we use on our racks, that VFD is a multi-speed compressor. 25 hertz is fine, but be very careful. Once you go above 60 to 70 hertz, that compressor likes to let a lot of oil go out the discharge.
Yeah, because it's carryover rate. You're spinning it faster, right? So the biggest thing is you got to get into the Bitzer software or the Copeland software or the Dorin software or whoever the compressor manufacturer is, and look at their limitations, and make sure that you're following their guidelines, right? Because I've seen contractors run it outside the guidelines, and then the compressor fails, right? Or run into a lot of issues with those compressors. Thank you for sharing that. Some of that.
This is the inside of the wheel separator. This is one of the. This is a smaller rack. This is a smaller than TSC05-13. This is one of Westemeyer's small one, because it's got a rod that comes up through the center of the filter, which means you get a 100% compaction on the gasket on the bottom. Reason I put this in here is when you start that rack up and you have 24-hour continuous operation, within 2 days to a week, you're gonna want to go through and change that separate filter. You're gonna want to change your separator dryers or your suction line filters, and clean out your filter dryers. I apologize. your inline filters. You want to take them, supply lines, take them apart, make sure that they're clean.
Yeah, because there's going to be dirt in the system. We try our best to keep it as clean as possible, but we're talking about thousands and thousands of feet of pipe. Some people are not as skilled as others, not as clean. I've done it. I know I made a lot of dirty systems out there, guys, but it's try to be better the next time. And so some of the things you will see is a high pressure differential across the oil separator would be one thing.
Yeah, you want to be careful. You want to look at it. Anything continuous 12 psi differential or greater. And what I mean by continuous is not momentarily, because you can have a 25 psi differential momentarily when something comes out of defrost and another compressor comes on. So a continuous differential of 12 psi, you'll want to change that filter. 25 psi will blow that filter out. Unlike a temp-right, you blow out the bottom O-ring. With a Westemeier, the way it's seated, it's going to blow the actual filter material out. And that becomes a nightmare you don't want to deal with.
Yeah, because now all the metal and stuff is in your oil lines and in your oil filters and could get in your components. When it blows out, is there a pressure differential across it? What will you see? If they go check, should it be zero across it?
I tell everybody, if you should have a minimum of 1 to a maximum of 12. If you have 0, you need to calibrate your gauges, or you need to look at that filter because it probably blew out on you.
Yeah,
there's no restriction.
Technician last week said he got 0 across, and I'm like, it must be your gauges because it wasn't blown out because they just changed it. So I'm like, hey, check the gauges, because that, and that makes sense. It's no different than an HSC system. That's the thing, right?
It's not.
So all the stuff that we really been talking about is like what we would be doing already. I think the higher pressures are at first intimidating, the more controls. But I've worked with startup guys for over, 20 years ago, and those guys were doing this stuff that we're talking about right now. Only it's a little smaller scale. There just wasn't as many sensors or temperature probes. This has been amazing. Why don't we, between me and you, go through what a startup checklist could look like? I'm going to say a few. So when you get there, because I've been to a few, you already said all after there's a good pressure test and evacuation, and you get say 150 psi charge, or you got 100 or 10 bar in the system of vapor, and all this stuff while you're doing your evacuation. This is where you're doing all your checks. Like, you know what I mean? So you're doing evacuation, but you got your pressure probes, like you said already, all your temperature probes. You check your phase monitor, make sure that works. You check all your relays. So you override like say if the liquid injection, you override the relay, make sure it turns on and off, your oil level controls. There's a process to do that. And maybe we could talk about that quick when you're adding oil to the system. Why don't we say the checks that you do, the way you do it, because it's different than other people, the way they do it.
Yeah, the way I do it is we pressure, we'll fill the oil reservoir. They fill the oil reservoir between the second and third vacuum, just like you would any other startup. You put your suction line filters in. Nothing changes. But we're not going to put any oil in the compressors. We're going to isolate it in the reservoir. And once I get on site, then what we're going to do is we're going to go through all our checks, as Trevor just mentioned, and then we're going to see stuff work. So what we're going to do is we're going to isolate the vent to the receiver, vent to or the flash tank, vent or the DOS solenoid supply line, and leave open the isolation valve to the compressors, and we're going to pressurize the receiver, that oil receiver, to 300 pounds. This is the only point in time I'll tell you to use a regulator. That way it's easy to maintain our 300 pounds and we can fill up our compressors. I'll turn on number one. I want to see it fill. I want to watch it go up and I want to watch it stop. And one of the things you want to do is once you get that one done, don't turn the switch off, because I've noticed in the past where we isolate the number one, we turn the switch off, we go to fill number two, then when number one starts to get low again. So leave the switch on, let it work while we're sitting there idle. Fill up your number two medium temp, number three, number four, however many medium temp compressors. Fill the reservoir as required for oil. Then you'll start with your low temp and fill all your low temp compressors up. We want to see the switches come on, shut the flow off.
Yeah, that's amazing. Right? And I love that. And then it's all the other checks, like all the case controllers, temperature, pressures, they're all wired, they're landed correctly, overriding different solenoids, and just make sure it all works. And this is a process. You got to make your own checklist. Yep. But the big thing is that these manufacturers, they supply the checklists for you. You know, they might not have, okay, there's 1,200 pressure transducers on the site. Go check it. They say check all the pressure transducers. So that's your responsibility as a technician. I know at every case, we're going to have a transducer, or at least every, maybe 3 cases, depending if you have one in every case or one on a main branch. You know what I mean? So it's our job to go around and test all this. Paul, this has been amazing. You know, I learned so much.
Yeah, the one thing the control system brings to us, it's a centrally located diagnosis machine. You can see everything from there. You can see your case controllers. You can see your alarms out of your case controllers. You get your alarms out of your rack. You go in your alarms, you find out what you got for an alarm, then you start there. You know, you're not trying to guess what's going on. You have something that just told you, hey, look here first. You know, if you went off on high pressure, but you got an alarm 20 minutes before that your vessel pressure was out of spec and too high, what are you going to look at? You're not going to look at your high pressure valve because a maximum operating pressure in the receiver has been reached. So that's going to shut off the HPV valve. So we're going to go, okay, well, what was the very first alarm is where I tell everybody to start. They want to start reading everything up. It says, no, go back and tell me what the first alarm is, and that's where we're going to start. So what he told me was, oh yeah, my receiver pressure went to 620. It's 620, 40 bar on a Danfoss system or Corel. That's just the HPV valve off, because all of a sudden it's saying, all right, look, I've got excessive pressure in my vessel. I'm getting close to the relief valve. I can't control it, so I need to shut this down. I can't take any more pressure. So now I need to find out what's wrong with my bypass valve. Turned out that the bypass valve, somehow the gear stripped out in the bottom and it quit manipulating the valve. So fortunately, they had a bypass around the bypass. We were able to open that up and then get the rack back up and running. And I think he also had to add an extra gauge line from the vessel to the suction line because it was summer and he needed to get more pressure out of there. But we got it running. He ordered a valve, took the valve apart, placed all the guts, put the valve back together, off we went.
Yeah. This part of our jobs as a technician, either in service or in startup. And until you're doing it consistently, that's how you get better. You got to get your hands. We're here, me and Paul are doing a great job talking about it, but I'm only getting better going out to the field and hanging out at a site with contractors or with the manufacturers, learning on those processes. And this is how Paul's learning. He's out there doing it. And this is how you're only going to get better, is going out there doing it. Paul, thank you so much for taking the time, sharing your wisdom with us and all your experience, because there's so much more to it. We could spend 10 hours here straight and we'd be just touching the surface. Paul, thank you so much for taking the time to come on to CO2 Experts. Any final thoughts for technicians? Any final thoughts for technicians who are maybe going to their first startup, or if they're doing some startups, and some tips and tricks over and above of what we talked about?
Well, first thing is, if you're new, it's your first CO2 rec, don't be afraid to ask questions. Don't be afraid to get in there and actually help. Hey, what can I do? What does this do? How do I do that? How do I put oil in here? You know, I've had guys fill up an oil reservoir with 500 pounds of pressure on it. And that's what I like to call a learning experience. I let him do it. He put his first can in. And then I said, well, you know, me, I would isolate it and vent the pressure out. Think about what you're doing. I had a term, you know, I hate using it, but it's called CO2 stupid. That when you walk up to a CO2 rack, it's all of a sudden thermodynamics are throwing out the door. Nobody understands how this rack works. It's, oh my God, it's a CO2. Who cares? It's refrigerant. It's ammonia is a refrigerant. Water's a refrigerant.
No, it's
just
true.
Ask questions.
Yeah. And there's lots of resources out there. Take trainings. Like, you're here listening, but you got to go take more trainings. There's lots of them out there. You got to spend the time, invest in yourself, get better, share this knowledge too. Whatever we talked about today, go out and share it. Go talk to someone about it. Go talk about how the process works, and then come up with your own process, because we're just touching CO2. We're in 10, 15 years of CO2, newer North America, but we had 50, 60 years in HFCs. That's a whole learning curve for 50 years. In the next 10 years, we're going to be so much more advanced with CO2 and natural refrigerants. We won't be even having these basic conversations. But Paul, I want to thank you so much for taking the time. Look forward to connecting with you again.
Thank you for having me, Trevor. Always great talking to you.
Awesome, everyone. See you all later.